Alright, so today we have a switching power supply. It is a 120 volt in, 5 volt out. I think this is just a little 5 amp. Could be a 2 amp. Don't know. Don't really care. Either way. So this belongs to a friend of mine. He's got some Asus switches, and unfortunately, the switches stopped working. And he popped them open and he checked them and found the power supplies were no good. So he didn't have any caps handy, so I just grabbed it off his bench and said, "Here, I'll just fix this for you and bring it back." So anyway, I'll show you what's the problem here. These two caps, if you look closely, you will see that they are domed. There we go. These guys here, they're domed. So I'll bring it up a little bit closer there. Again, still playing with the lights and microphones and stuff. We're getting there, folks. I don't have the money for big lights. So anyway, you'll see that these guys have ejected their goo right there. So they have gotten too hot and bothered, and they have ejected their goo all out the top and stopped working. And so has this one over here in the corner. These ones here are 1,000 microfarad 16 volts. I'm replacing them with 1,000 microfarad 25 volts. The one in the corner there is a 470 16. And then the bootstrap cap, which is right down there, which is responsible for the operation of the switching power supply. You'll find more often than not, if you have a switching power supply and the thing looks like it's working perfectly, or should, and it's not, if you change that cap, it'll probably start working again. That little guy right there. Right there. They're usually about, let's see here. I've got one right here in my hand. It's usually about, 22 microfarads. 22 to 50, depending. I've seen them all over the place, but usually the can looks about that big. So, yeah, here's what we're going to do today. So, this is just a quick repair video for you. So we've got negative stripes out here. I'm not sure if that's even marked on the board. It looks like it is. So I'm just going to cheat here, and I'm going to take out my wet hot air tool. And just, casually heat these guys up. And I'll just pop them off the board. Do-do-do-do-do. Could use a soldering iron, but, just for shits and giggles, why not? Do-do-do-do-do. Is that hot enough yet? Nope. Do-de-do-de-do. Alright, it looks like it's hot enough. There we go. There's one cap. I did that cool trick with my finger. So, my hands are not as nimble as those of some of the other amazing internet technicians. So there's two caps out. Alright, use the hot air gun. I'm lazy. Alright, so now just clean up these little pads here. So I will grab a soldering iron. Fluff it a little bit. Now, let's see here. That fluffing did not work. Alright. There we go. That's better. That's much better. Okay, so let's take this off. I actually ran out of solder wick, by the way, but I wanted to make a video. And so this is actually a good opportunity for me to show you what to do if you do run out of solder wick. Usually if you keep your tip clean enough, your tip will actually absorb some of the solder for you. And then you just wipe it off. Like that. It's not, trust me, this is not best practice, folks. But, I'm trying to keep it real. This happens to technicians so many times, especially when you're out at a radio tower at like 3 in the morning and you're trying to fix something because you've got a bunch of screaming, freaking out people offline without internet, yes, at that hour in the morning. So, yeah, you got to do what you got to do. So, oh shit, I forgot this, or oh shit, I forgot that. Well, here's what we do if we are without this and that, okay? So there we go. We got this little guy here. I'm just going to give it a little twist. This is something else I do, which is probably bad practice, but you know what? You gotta learn all the different tricks. Okay, so then we got a little bit of solder here. I still like to use just a touch of flux. I will take the flux off afterwards. I just find it so lovely the way that it makes everything adhere. Alright, so we've got this guy here. Now remember, you want to apply the solder to the contact point, not necessarily to the tip of the soldering iron. Okay, that's a nice solder. I like it. Just put a tiny little bit more on there, just for shits and giggles. There we go. Okay, so that's one point done. Alright, let's get the other one on here. The vias look pretty clear, so I probably won't have to struggle as much to get it in there. I'll order some solder wick. Don't worry, folks. I'm not a complete hack. Okay, so there we go. Once again. Do. And in the comments below, you know, if you see me doing anything which you would suggest you can do better, tell me how to do it better. I don't care. I'm always up for learning. That's why I'm doing this, is I'm trying to interact with the community out there so that I may learn myself and teach others what I do know. That's the whole thing about our species, how we kind of evolve through things, you know. We share information with each other. Alright, so there's those two caps. Where's my little cutters? There we go, just nip, 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 nip. Alright, so there's those guys. I'm just going to trip it off a little bit more. I like these ones for doing the basis circuit boards, but, you know, we also have these. Everybody loves these. These are great because you just get in there and they're actually for this purpose. It's just I like these because you come in from the top and it's the same level. Everything's happy. Okay, so that's those two caps. Let's get to this little guy in the corner here, which is going to be a bit of a bugger to get to. So I'm going to get in there with a... there we go. I'll just get in there like that. And if we're lucky, I can pop it out with the hot air as well. You gotta be careful with your hot air gun. If you're like me, you're gonna burn yourself all the time because I'm stupid. Okay. Refurbishing a circuit board. Yay. Yeah, I'm burning my fingers right now. It sucks. We up to 450 yet? Are we up to 450 yet? Come on. Get out of there. Ah, there we go. Okay, so that's out of there now. And there we go. So negative's pointing out. So here's a neat little trick too. You probably can't see this from there, can you? Yes, on that angle. Do you see how one side has is filled in like a half moon? It's filled in white. That's your negative indicator. So that's your negative side. All right, so let's clean this guy off. Once again, I do not have any solder wick. There is a really handy trick for solder wick, which I'll show you guys in another video. You can actually use a piece of stranded copper wire with some flux, and it works great in a pinch. And because I always have flux, I always have solder wick. Works pretty good that way, right? All right, here we go. Second one going in here, third one. In the hole you go. All right, will you fit? He will not quite fit. So what I'm going to do here is I'm going to show you guys another little trick. Okay, so we need a couple of little pieces of, just because this cap is just slightly larger, I'm going to show you guys a really handy trick. Sometimes you don't get exactly the same physical component that, you know, was originally in there. Especially when you're working in the guerrilla warfare mindset, which a lot of field technicians end up doing, unfortunately, not by choice, but just by the fact that it's the nature of our jobs. Not a great thing. Alright, this is a heat shrink. So, if you look here, you're going to see how long this is. So, I'm going to cut this off just about the right length. I'm going to make another one just about the right length. There we go. Now what you do, once you have these guys on here, is you simply slide them onto the legs like so. And this is standing off the board. If I was working with high voltage and stuff, I would probably just say screw it. And I would order a better suited capacitor. But we're working with a little 5-volt power supply here, and we're not working at the high voltage side of things at all. So this is perfectly fine. Okay, so you see the heat shrinks on the legs now. So this now ensures that they're not going to short out. So now I can slide this bad boy through and do what I did before. You know, give the legs a little bit of a twist. Oh, tiny bit of flux. And I'll show you how to clean this board up too when I'm done. I use rubbing alcohol. A lot of us in the industry call it ISO. If you make hash oil too, I mean, like, that's another thing. People usually use ISO, which makes it really embarrassing because I don't buy it in bulk like a lot of guys do. I just go to the pharmacy and buy it, and when I go and buy 4 bottles of it, they look at me like I'm making drugs. And it's like, no, I'm dead serious. I'm not lying to you. This is not for making drugs. I am honestly making electronics or working with electronics, okay? So, I should get my ISO ready anyway. Where did I put that? I'm never well prepared. You're going to learn that through my videos. I'm not a very well organized or well prepared individual. Not by any stretch of the imagination. Okay, so there we go. Last cap. That's a bugger. That's right down in there. Okay, so that guy there, I don't know if I can use the trick that I used before with my little boop. Let's see. Are we lucky? Might be. Yeah, let's find out. This guy here I could probably pop out with the soldering iron, so yeah. Come on. Come to mama. Ah, where we go. There we go. Got it out. Yeah, I love this. Okay, there we go. So let's clean this guy up a little bit so we can get in here. Sounds like my microphone's a little bit hot. I will adjust it for the next video because I'm already almost through the video and I don't want to screw with my audio settings because I'm recording audio on a separate device now. Alright, so this one here should go straight in. So we will just, there we go. A little note as well. The shorter lead is usually your negative. There we go. Okay, that's in there. Let's pull it up because it's so far down in there. Get in there. Alright, there we go. It's nice and tight fit. Okay, so there we go. And this one here, you know what? I might not put any flux on it just because it's so tight. Clean my solder tip right there. There we go. So I'll make one leg stable before I go to the next one. There we go. Okay, so that's nice. I don't like that little smear there. Okay, yeah, that's just because the way that the board was etched. No big deal. Okay, and then once again, we are going to do one of these. There we go. Nice and clean. So now this is where we have to clean up. Nothing pisses me off more than when I do work on a professionally done circuit board. I'm talking something that came from the factory, and the guys at the factory, they don't put any love at all into their work. Best practice is you always want to clean up when you're done. It just disgusts me when I come across a circuit board that's it's covered in leavings, factory leavings. Let's see here. There we go. Okay. Let me use a little bit of toilet paper here first. Just get the bulk of the flux off of here. Okay, so now I've got the bulk of the flux off, and I've got the toilet paper off. So now let's actually get in here and clean. There we go. Again, ISO, 99% isopropyl alcohol. That's what you want when you're working on circuit boards. It's great for fixing things that have gotten wet too. Takes off all the resin and other crap that's stuck on the board that makes it look like crap. And then when you're all done, a little bit of that. Sorry about the noise. Alright, that would be a, there we go, that's the air. I use compressed air. So now, as you can see, I've got the new caps in there. Everything's happy. Now, here's a little something that they don't teach you in school as well. At least I don't think they do. It's been a long time since I've been in school, and I got kicked out of many of them. So, this is going to be in a switch, so it's not going to be in a really high vibration area. It's not going to be rugged. But when you've got caps like this, just something which I really like to do is just put a little blob of silicone on them, okay? Not a lot, because this will make it hell for you in the future when you have to change them, okay? Which inevitably we all end up doing. But if you put a little bit of silicone on that, what it'll do is it'll stabilize them. They can lean on each other now. See what I did? So there's a little bit of silicone on there just to stabilize them. Okay, so now it comes to the final step. We need to test this thing. Well, I'm going to show you boys and girls how to do something extremely dangerous but lots of fun. Do not do this at home unless you are in fact a professional who's been doing this for quite some time, like, you know, me. But even then, that can result in, you know, horrific electrical shocks. And I am in Kazakhstan here, and around here it's only 120 volts and 60 hertz, so yeah. Alright, so here we go. So I'm just going to tippity tap this guy on here. This way I can boop. Just gonna, let's see here, which one's my neutral? Which one is neutral? Okay, so neutral's indicated on here, so yeah, you go here. There we go. Guess there's one. And then clean the tip. There we go. Now remember, folks, this is not recommended unless you are very careful and you know what you are doing. Sometimes I don't. Okay, so now we've got our, there we go, we've got our board looking good. And we've got our test set up. This, by the way, that I'm working on, the surface is called anti-static mat. It's actually slightly resistive, and that allows for you to not fry shit. It's actually grounded, okay? Which one might say, oh, well, then you're going to blow that thing up as soon as you plug it in. I just might do that, actually. So why not take an extra precaution? I'll just go like this. And then that way I can also get at the contacts for the, here we go, for the 5 volt, which is like right here. Okay, so there we go. We got that. I'm going to plug it in. And let's see if it blows up in my face. Maybe I'll pull an electro boom here. By the way, he's another one of my favorite Kanekistani YouTubers. Oh, it didn't blow up. That's a good thing. Alright, so let's see what we got here. Alright, we got 20 volts DC. Let's see what we got. Alright, so we got ground on this side. I already looked at this thing in the ASIS, and ground is on one side, positive is on the other. So if you look there, you will see we have got 5.13. If this was a mission critical situation, I would load test this as well, which means I would put a 5 volt load on it at the rated amperage of the output on this to ensure that it doesn't bottom out. But it's pretty obvious what happened here. The cap's popped, so we don't really need to do that. So that being said, I believe that she's good to go. I will unplug her now and hopefully not blow myself up. Well, it's there should be discharge resistors on here. So just to keep in mind, folks, by the way, like right there, that is a 400 volt rated cap. That's probably got about, don't make me calculate, it's probably 160 volts DC running through it right now because it just charged, unless they were smart and they put a discharge resistor on it, which they don't always do. Okay, it's a little safety feature. Alright, that's done. I'm just going to tidy that back up. There. You know, you always want them to look like little mountains. Nice and clean. Good to go. Okay. So yeah, there you go, folks. That is a quick 5 minute, 5 volt, whatever amp power supply repair. And yeah, now I can give this back to my buddy, and he'll be very, very happy to get it back. And actually, I'm going to take one of these MOVs here. Oh, I didn't even notice that. That's not a good thing. That thing actually wasn't even soldered in. You see, this is what bothers me about manufacturing, actually. It's a good thing I caught that. Is that a lot of this stuff is manufactured bottom dollar. And then they ship it out. And there's these weird issues that people get with stuff. There we go. Alright. Yeah, it's not really wicking well onto the leg there. Unfortunately, the leg is crimped. No, that's pretty solid. I'm not entirely happy with that, though. There we go. I'm going to push it through a little bit so I can actually see the bottom of the leg poking through the solder. I just didn't like that. Actually, now that I noticed that, let's just do a quick double check. So what I'm looking for here is what's called cold solder joints. A cold solder is when either the solder did not adhere to the leg of the component, or just over time and vibration, the connection between the solder and the leg has come loose, and you get a little bit of an air gap. Here's something else I like to look for, by the way, is little bits of solder to get on there. But again, one of the last things I like to do when I'm done is give it a little scrub. I like my circuit boards clean. There we go. Okay, that's really clean. Okay, I like that. That can go back in my brushes. Goes in the pokies. That goes over there. Okay, and then that goes over there. And then we'll give this thing a quick dust off again. Make sure it's not inside. Silicone's still on there, but gross. There we go. Alright, we have a working power supply, folks. Alright, so that's how you do it. That is a quick repair for any of you network technicians who have a switch that has gone tits up on you and is not working. Now, actually, yeah, I think that's long enough. I've rambled on long enough. Again, comments below if you guys want to see or hear anything or correct me on something that I've done. Otherwise, keep on learning and have a great day.